Okay, question 4. Two loudspeakers, they're in phase, emitting sound waves, same amplitude and frequency, and we have been given these distances to a point P, and we have to deduce there's a minimum intensity at P. Okay, so we know that the path difference is a very important concept. In interference problems, we can work out that very easily, 1.8 meters. That has to be compared with the wavelength of the sound wave, so we can work out the wavelength using the wave speed formula. We know the speed of the sound and the frequency, so we get a wavelength of 0.4 meters. And then we need to compare these two, of course, how many wavelengths fit into that path difference. Take the ratio and we get this half integer, 4.5, so that's a half integer multiple of the wavelength, so we know we're going to have destructive interference and therefore a minimum intensity. Okay, remember if it's a whole multiple of the wavelength you get constructive interference, but half integer multiple you get destructive interference. A wave crest meets a wave trough and cancels out. Okay, next one is now we're moving the microphone from P to Q along this line. So we know we're going to be moving through a series of maximum and minima, right? A normal interference pattern. At Q, right in the middle, we have a maximum, and then we're going to, as we move, say we move upwards from Q to P, then of course we're going to first encounter a minimum, and then another maximum, and a minimum, maximum, and so on. And remember, we can actually label these maxima and minima if we know exactly how many multiples of the wavelength the path difference is, and so on. So we have n equals 0, n equals 1, and n equals 1/2, n equals 3/2, and so on. That's how we can label the maxima and minima. But yeah, so the intensity is definitely going to vary as a series of equally spaced out maxima and minima. We're going to start at a minimum at P, and then we're going to work our way through all those maxima and minima until we arrive at Q, where we have a maximum. And they're not sort of asking for too many details, but this should give you those 2 marks. Okay, next one is the usual question that one of the loudspeakers is turned off. B is turned off. We know the intensity is proportional to the amplitude of the wave squared. So the ratio of the intensities will be equal to the ratio of the amplitude squared, and since we halve the amplitude when we remove one loudspeaker, then we're going to get 1/4. Okay, so since this is a higher level paper, we have this Doppler effect question now. Microphone moving away from the loudspeaker. We have to explain why the frequency is lower. So this is the Doppler case of a moving observer. So the speed of the wave is unchanged as it travels through the air. So the speed of the sound wave relative to the microphone, because the microphone is moving, the speed of the sound wave is reduced, is lower, because the microphone is moving away from the wave. So the microphone measures a lower speed of the wave, but the wave length is still the same. There hasn't been any compression or stretching of the wavelength, so the wavelength is unchanged, and therefore the frequency is going to be lower because of the wave speed equation. V equals lambda f. If V goes down, then f goes down when lambda is unchanged. Okay, then we have to now calculate the speed of the microphone. Okay, so we have to use one of the Doppler effect formulas. So in the formula booklet we can write down the moving observer formula. The microphone is the observer, it's moving, but there's a trick here, so be careful, because in this problem the speed of the microphone is labeled as v, but in the equation v is the speed of the wave, which is 340 meters per second, and u, the speed of the observer, is what is labeled V in this problem. So it's very confusing. So get that straight first. And then, of course, is it the positive or the negative sign we have to use? And because the frequency is lower, then the expression in brackets has to be less than 1. So we have to use the negative sign. And then we can just rearrange and find V. And we get 2, and we're going to give it to 3 sig figs because all the numbers are given to 3 sig figs.